Hello everyone. In this video lecture we are going to study about the solution of PI case of linear homogeneous partial differential equation, the remaining two cases which was not taught in a previous video. One should be able to, in the learning outcome phase, one should be able to understand the following concepts, the remaining two rules of finding the particular integral. Fourth case is when function fx is of the form x to the power m into y to the power n. That means the pi is equal to 1 over f d dash into x to the power m y to the power n. Now point to remember, if m is greater than n, that means the power of x is more than y, then 1 by f d dash should be expanded in the power of d dash upon d. That means you have to take common d from the denominator side. From the denominator you have to take the d, capital D, as a common. If n is greater than m, that means the power of y is greater than power of x, then we should expand binomially by the power in the power of d over d dash. That means we have to take d dash as a common from the denominator. Now for the example, d square minus a square d dash square d is equal to x to the power 1, and we can say that y to the power 0. So to find out the pi, 1 over d square minus a square d dash square x, because the power of x, that is m, is greater than n, so we have to expand the denominator part, this denominator term, in the power of d dash by d. So we are taking d square as a common, so that the remaining part in the expansion will be in the form of d dash over d. So we have considered the d square as a common, complete d square as a common. So d square is common, denominator is 1 minus a square d dash over d whole square. Now taking this term on the upward, 1 by d square and 1 minus a square d dash by d square whole power minus 1 into function x. Now by expanding this term using the binomial expansion, so 1 by d square is same. Expanding this term, we get first term as a 1, second term is plus of a square d dash square by d square plus so on, and x is same. Now when we multiply this d square with when we multiply this x with the left side portion of the binomial expansion term, we get only the x, and because the differentiation of x with respect to y twice is 0, so the remaining term is 0. So all the terms after the 1 is 0, so it is neglected. Only the x into 1 is remaining, so x into 1, and 1 by d square is outside the bracket, so 1 by d square. Now we can integrate x with respect to x twice, because capital D is equal to d by dx. But if we are saying fx over d, that means the integration of fx. If we are saying 1 over d square and fx, that means double integration of function fx with respect to x. So double integration of x will be x cube by 6. So this will be the pi. Let assume if the power of m, instead of this x into y to the power 0, we have fd d dash z is equal to y. That means the power of y is more than power of x. In that point, we have to consider d dash square as a common, and denominator part over here will be d over d dash square minus a square into y. This will be the terms. You have to remember this point, that if the power of x is more than power of y, then we have to take d as a common to convert the binomial expansion term, and if the power of y is greater than power of x, then we have to consider d dash as a common and expand in the power of d by d dash square. Now it is a general method. Fifth is a general method case in which the pi is equal to 1 over d minus d m1 d dash, d minus m2 d dash, and so on, and function of xy. Remember over here the m1 and m2 and m3 or mn are the root of the auxiliary equation. So to solve 1 over d minus m d dash into function of xy, we just consider y is equal to c minus mx. That means y is equal to c minus mx, and we replace the value of y in a function of x, y. In a function f, we replace the value of y over here and integrate it with respect to x. When we integrate this portion, after integrating it, we again, because after integration we have a term which include this c, this constant c, so we have to replace the c. That means from this portion we have to evaluate c is equal to y plus mx, and we replace the value c with y plus mx, and we get the pi for particulars this portion. Now similarly, if the value of m is plus over here, then the value of y is equal to c plus mx. That means we have to replace complete y in a function f as c plus mx, integrated with respect to x, and then the terms after integrating it containing the c. To find out the value of c, from this equation we evaluate c is equal to y minus mx. We replace c as y minus mx, then this portion is solved for the pi part. Now considering the example that solve d square minus d dash minus 2d dash z is equal to y minus 1 e to the power x. So as this is the case which is not taught in a previous courses, previous topics and previous cases, so we will use the general method. To solve it, first we have to find out the auxiliary equation. That means d is replaced by m and d dash is replaced by 1. So we get this auxiliary equation. We have to find out the root, and the root of this equation is 2n minus 1. Now the CF will be f1y plus m1x plus f2y plus m2x. Now so this is the roots. Now we have to find out the pi. According to the pi, 1 over d square minus d dash minus 2d dash y minus 1 e to the power x. So we have to split this term in terms of factor form. So because we know that the auxiliary equation is produced by the d and d dash equation from this equation, so we can split it by using the roots. So over here we have root, so we just replace d plus first root minus first root, that is minus 1 d dash into d minus second root is 2d dash. After solving it, we get d plus d dash and d minus 2d dash. To check and cross verify it, you can multiply this term separately and the term product should be equal to the previous term, this. Now by using the PI case according to this formula, first we will reduce to solve this portion d minus 2d dash. Now comparing it, we find that the value of m is minus 2. The value of m is minus 2. From over here we find out that the value of m is minus 2. Then the y is equal to c plus mx, and the value of m is minus 2. So we have y is equal to c minus 2x. So y is replaced by c minus 2x in this function. When we replace the y with c minus 2x, the value of y is replaced by c minus 2x. 1 is same and e to the power x is same. Now we have to integrate this with respect to x. So we use the Euler's method or by part method, because over here we have two terms. First is this, second is this. Now, and this 1 by d minus d dash is same. First term is same, that is c minus 2x minus 1 is same. Integration of e to the power x is e to the power x, and then minus integration of differentiation of this term will be minus 2, and again integration of e to the power x is e to the power x dx. So minus minus plus, and again we integrate it, then we get 2 e to the power x, that is 2 e to the power x over here. So we get the integration part over here, and after solving it we get the term which is containing c itself. So 1 by d plus d dash c e to the power x minus 2x e to the power x e to the power x. So this is the solution, but this c should be eliminated because the value of c is calculated from this equation where we substitute the value of y. So c is equal to y plus 2x. C is equal to y plus 2x. We replace the value of c. Simplify this complete term. We get 1 by d plus d dash into y e to the power x plus e to the power x. Now our first partition of this d minus 2d dash is solved. Now we have to solve for d plus d dash. Now when we have to solve this d plus d dash, the value of m over here is 1. So the equation of line is equal to y is equal to c plus x. So y is equal to c plus x. That means we have to replace y with c plus x. Now we replace the y, this y, as a c plus x over here. We replace it as a c plus x, and then we have to integrate again with respect to x. Remember, when you replace the value of y as a c plus x, you don't require to write this d plus d dash, because this portion is solved. As soon as you write y is equal to c plus x, this portion is solved. Now we have to integrate it. After integrating, we get this term, and again in this term we are having the term c, and the value of c is calculated from this line equation because we have substituted the value of y in terms of c. Again we calculated the value of c, that is y minus x. We substitute over here y minus x, and we get that pi is equal to y e to the power x. This is the final pi of this portion. This is the solution of this portion. Now the final solution should be containing cf plus pi. So y is equal to z is equal to cf plus pi. So this is the final solution by using the general method. So this is the summary of this video lesson. that in this lesson we have discussed about the rule of pi, two rule of pi for solving the homogeneous partial differential equation with constant coefficient. One of the rule is for the general method. Thank you for watching the video and stay home, stay safe. For any doubt and any query, feel free to contact your concerned faculty.